Note on this screen that we looked at earlier that the ones digits in the third row in column 2 and column 8 are complements, a 6 and a 4. And the ones digits in row 9 are complements, an 8 and a 2. This is true in every row. The answer in column 2 and the answer in column 8 have ones digits that are complements of one another. Here we're looking at row 4. The boxes marked in red, 4 times 1 and 4 times 9, total 4 times 10. The 4 in the first red column and the 6th in the 9th red column are therefore complements. The same is true of the second column, the 8, and the 8th column, the 32. As in all the rows, here in row 7, the times 1 and the times 9 are complements and total 70, 2 and 8 total 70, 3 and 7 total 70, and 4 and 6 total 70. The ones digits in these complementary columns are always complements. The same thing is true in every column. Here in the 8th column, 1 and 9 total 80 and are complements. 2 and 8 total 80 and are complements. 3 and 7 total 80 and are complements, and so forth. Here is column 2, where the complementary pairs total 20. Let's go back and look at the multiplication chart and look at 6 times 8 and 4 times 2 again. Here we have 6 times 8 and 4 times 2, 4 and 2 being the complements of 6 and 8. Let's look for a second and see what happens if we were to multiply one of the rows by the other column. Let's multiply 4 in the rows times 8 and see what happens. Row 4 times column 8 is 32. Row 6 times column 2 is 12. I've marked the 12 and the 32 in this chart. Notice that they form the opposite corners of a rectangle, with 8 and 48 being the other two corners. We'll focus our attention on 3 of the corners of that rectangle, 8, 32, and 48. The second column and the 8th column are complementary columns. 4 times 2 is 8, and 4 times 8 is 32. 2 4s and 8 4s will naturally total 10 4s, or 40. Now we look at 4 8s and 6 8s. Because they're in the 8th column and they are complementary problems, they will total 80, just as 8 and 32 in complementary columns totaled 40 in the 4th row. This is the key idea to understanding this approach. Two numbers that are complements of the same number must be the same. If 8 is a complement of 2 and 48 is a complement of 2, the 8's must be identical. The 8 and the 32 must equal 40, and the 32 and the 48 must equal 80. There's no way that the 8's could be anything but identical. Let's make sure we understand this. Before we go on, here's a puzzle for you. You're given two numbers, 40 and 80. The same number is to be subtracted from each of those two numbers. You were not given the number to be subtracted. Instead, you were given the answer of the subtraction from the small number. It's an 8. What will be the answer after the subtraction from the larger number is the question. The catch is you're not allowed to figure out or use the amount subtracted. How can it be done? Looking at this graphical representation of the problem, it's easy to see how it can be solved. The big black question marks indicate the amount that we don't know and cannot know that's going to be subtracted from 40 and 80. The 8 is the amount that we do know is the result after subtraction from 40. What we don't try to do is figure the answer in the 80 column directly. What we do is figure out how much more that answer will be than 8. And it's pretty easy if you look at this chart to realize it's going to be 40. The difference between 80 and 40. You add 40 to the 8, which would go below the dotted line, and the answer would be 48. Here we look back at row 4 and column 8. In row 4, the 8 and the 32 totaled 40. In the 8 column, 32 and 48 totaled 80. Notice that the total in the 4 column is 40, and in the 8 column is 80. We now know that the difference between 8 and 48 can be determined by subtracting the total at the end of the 4's row and the total at the end of the 8's column. Subtract 40 from 80. But if we can take a little jump and think of the 8 in 6 times 8 and the 4 in 4 times 2 representing 40 and 80, all we have to do is subtract 4 from 8. Look at the number, multiply it by 10, and we have the difference. 8 take away 4 is 4. 4 times 10 is 40. And there's the difference between 6 times 8 and 4 times 2. The exciting thing is that we don't have to know anything about this graph. Nothing about the rows, the columns, the totals of complementary columns, the fact that 4 times 8 is the point where the row and column meet. We need to know nothing about that. All we need to know is that the column in the first problem is 8 and the row in the second problem is 4. Subtract 4 from 8, multiply by 10, and we have the difference. Check these problems and you'll see just what I mean. If you subtract the row in the bottom problem from the column in the top problem, the 4 from the 8, the 4 from the 9, the 3 from the 8, and so forth, multiply the answer by 10, and you have the difference between the two answers. For instance, on the bottom of the first column, subtract 2 from 8, you have 6. That gives us 60, the difference between 64 and 4. At the top of the second column, you subtract 1 from 9. That gives you 8, which results in 80, which is the difference between 81 and 1. Continued in part 4.